Yes, sir. The timetable says it's 3
It's
to
three
4,
to,
but your
yeah,
email
yeah.
says
So
it's
it's
4.
not matter. We are
Yeah.
going according to the timetable, no? It may be mistake, right?
Yeah, many people have already left, sir. I don't know if
Why
they
the,
will
why
come
the,
back.
why they have left, yeah? You
I
just
don't know, sir.
ये
Yes,
ग्रुप
sir.
में आप ग्रुप में डाल दो, आप ग्रुप में डाल दो, क्लास स्टार्ट हो रही है आपकी, है ना?
Yes, sir. डाल दिया.
ठीक है ना, ग्रुप में डाल दो.
Yes.
Class is from 3 to 4 p.m. Yes, last class what we have discussed. Last class हमने क्या डिस्कस किया था? Yes.
About analysis about DGA and DSA.
We, yes, anyone?
So we were discussing
We
about.
have discussed about TGA and DTA. DSC we have
No,
discussed.
sir, we have to start from there.
Yeah, we have to start from DSC. No, that is differential scanning calorimetry. We have already discussed differential thermal analysis and thermogravimetric analysis. So, what you understand by thermogravimetric analysis? If I am saying thermogravimetric analysis, yes, yes, anyone? Yes, anyone?
तो ग्रेविटी से रिलेटेड है कुछ?
ग्रेविटी से रिलेटेड है? क्लास नहीं किया हो क्या? ग्रेविटी से रिलेटेड है तो क्या चीज
मैं
ग्रेविटी से रिलेटेड हो
सर
सकती है?
मैं 2-3 क्लास से मतलब था नहीं, मतलब बाहर गया था नहीं, घर में कुछ काम से गया हुआ था.
तो आपको कम से कम मैंने आई थिंक आप लोग को लेक्चर नोट्स भी मिल गए हैं क्लासरूम में, है ना? अपलोडेड है सब? यस.
Yes, sir.
So we have discussed TGA, thermogravimetric analysis, and DTA, differential thermal analysis. So we'll start with DSC, that is differential scanning calorimetry, right? So I will just share my screen. Yes, the screen is visible to you. Yeah, the screen is visible to you.
Yes, sir.
Yes, sir.
DSC. So DSC, that is differential scanning calorimetry. Calorimetry means heat flow in a sample. That is the heat flow in a sample, and differential calorimetry means heat flow in sample versus reference with respect to function of time. It means we in DSC we are going to measure the heat flow in a sample with respect to a reference and with respect to a function of time. In TGA, we are measuring the change in mass with respect to change in temperature. In DTA, we are measuring the temperature difference of the sample with respect to the reference. And in DSC, we are going to measure the heat flow in sample versus reference with respect to function of time. Now, DSC is a thermoanalytical technique in which the difference in the amount of heat required to increase the temperature of a sample and reference is measured as a function of temperature. So it is a thermoanalytical technique where the difference in the amount of heat required to increase the temperature of a sample and reference is measured as a function of temperature. Here, both the sample and the reference are maintained at nearly the same temperature throughout the experiment. And generally, the temperature program for a DSC analysis is designed such that the sample holder temperature increases linearly as a function of time. And the reference sample should have a well-defined heat capacity over the range of temperature to be scanned. Now, what is heat capacity? We are going to measure the heat capacity. So when we start heating our two pans, for example, you will see the instrumentation here. We will discuss the instrumentation. These are the two pans that we are going to start heating, right? One is the sample pan and the reference pan. So when we start heating our two pans, the computer will plot the difference in heat output of the two heaters against temperature. That is to say, we are plotting the heat absorbed by the polymer if you are taking a sample as a polymer against temperature. Then you will observe a plot like this, right? That is the heat flow versus the temperature. And if the heat flow is going to be shown in units of heat, Q supplied per unit time, and the heating rate is temperature T, is represented by heat by time, that is Q by T, is the heat flow. That is the temperature increases, delta T by T, that is the heating rate. So on dividing it by Q by T, you will get that is the Cp, that is the heat capacity of the system or of the material, right? So talking about the instrumentation of DSC, two basic type of DSC instrument have been commonly used. That is the power compensation DSC and heat flux DSC. So on the screen you are seeing that is a power compensation DSC and that is a heat flux DSC. Now one by one we are going to discuss what is power compensation DSC and what is heat flux DSC. Power compensation DSC that was introduced in the 1960, and in this type of operators, in this operators, both the sample pan and the reference pan are kept in two separate chambers, and they are thermally controlled, or they are being controlled by two different furnaces. So they are kept in two separate chambers, and the sample holder is consist of aluminum or platinum pan, right? And the sensors are platinum resistant thermocouple or separate sensors and heater for the sample and reference pan. So in power compensation DSC, two separate chambers are there, and there is separate sensors and heaters for the sample pan and the reference pan, and individual heater for the sample pan as well as the reference pan, that is the furnace. And the temperature controller supplied the differential thermal power to the heater to maintain the temperature of the sample and reference at the program value. So this temperature controller that is connected with the furnace provide a temperature to maintain the temperature of the reference pan equal to that of the sample pan. So the temperature that is required to maintain the temperature of the reference pan equal to the sample pan is measured in DSC. That is power compensation DSC. Second is heat flux DSC. So in heat flux DSC, you will see on the screen that it consists of a single chamber, right, in which both the sample pan and the reference pan is kept. Both the sample and the reference holders are in the same chamber. Here again, aluminum and platinum pans are placed in quantities. Sample and reference holder are connected by a low resistance heat flow path. Now here the thermocouple, here it is both this pan, that is the reference pan and a sample pan, is connected with a thermocouple, that is a junction between the two different metals that produce a voltage due to temperature difference. So this measures the temperature difference between the reference and the sample pan, and the temperature difference between the sample and reference is converted to differential thermal power, which is supplied to the heater to maintain the temperature of the sample and reference at the program window. So these are two types of DSC instruments that are that are power compensation DSC and heat flux DSC. So in detail, we will study how heat flux DSC work. So this is a pictorial representation of heat flux DSC. Here you will see that the reference pan and a sample pan both are kept in a furnace that is thermally insulated, and these sample holders are kept in an environment control equipment. And both this reference pan and the sample pan are connected with a temperature sensors, and the furnace is connected with a microprocessor control power source. You will see that the instrumentation is similar to that of yes, anyone? It is similar to that of yes. The instrumentation of DSC is similar to that of anyone?
TGS.
DTA. It's similar differential
Similar to TGS.
not
DTA.
TGA, that DTA, differential thermal analysis. Only the difference is that here you will see that a secondary power source is also connected with the reference and the sample pan. Now, what is the work of this secondary power source? The work of a secondary power source is to provide extra heat to the sample so that the temperature of the sample is equal to that of the reference, right? Or we can say that to maintain delta T equal to 0, that is the temperature of the reference and sample minus the temperature of the reference, that is delta T equal to 0, the extra heat that is provided or the extra power that is provided by the secondary power source. And this secondary power source, this power is measured in DSC, that is the delta H recorder minus T. So this recorder measures the secondary power, that is the power that is being utilized to maintain, or that is power supplied to sample or reference to make delta T is equal to 0, and that is measured in DSC. Clear हुआ आप लोगों को? Yes?
Sir,
हाँ जी।
some of the students who thought the class was from 4 to 5
तो काफी
are trying to join.
मुझे मेल किए भी काफी समय हो गया था ये चीज, है ना? मैंने मेल भी कर दिया, आपने इन्फॉर्म कर दिया. Still they are trying to join so late in the class.
Yes, sir.
Right?
They just noticed my message,
Oh.
so can you please read them in?
Yeah, I have added them, right?
All right.
Yes.
Okay.
Instrumentation is clear?
Yes, sir.
So, what is the role of secondary power source in DSC? Yes, what
Sir,
is the
it
role
measures the extra heat.
Maintain that delta T equals to
it
0.
measures the extra, it does not measure the extra heat.
Oh, sorry, it provides the extra heat.
Yeah, suppose if I am saying that I have taken a polymeric sample, right, and I have heated it in a furnace. Now, what will happen? There may be some endothermic or exothermic reactions that will take place in the sample. Suppose I am saying that some exothermic reaction is taking place in the sample. So the temperature of the sample chamber will increase or decrease?
Increase.
That will increase, right?
It will
Will
increase.
increase. So temperature will increase. So the secondary power source will not provide any power source will not provide any heat to the sample, so that its sample will be equal to that of the reference. And suppose if there is some endothermic reaction taking place, the temperature decrease, so it has to provide some heat so that the difference between the sample and reference will be 0. That is, the delta T will be 0. So the difference in the temperature, to maintain delta T is equal to 0, the power that is being used is measured in DSC. Clear now? Now clear everyone?
Yes, sir.
सर एक बार दोबारा बता दो.
कौन है अभी? किसने पूछा? अभी क्लास में आए हो?
नहीं सर, मैं पहले से ही ज्वाइन करने के कर रहा हूँ, एक्सेप्ट नहीं हो रहा था.
हाँ, एक्सेप्ट नहीं हो रहा था तो गलती आपकी है ना? क्या बताया मैंने? चलो, कोई मुझे बताएगा? Anyone want to explain this? Yes, anyone?
Yes, sir.
हाँ, explain करो.
If there is an exothermic reaction, the temperature will rise. So secondary power source will not provide any extra heat. If there is an endothermic reaction, secondary power source will provide extra heat to the sample so that the temperature difference between reference and sample is zero.
Yeah, to maintain delta T is equal to 0, if you are comparing the two instruments, that is a DTA and a DSC instrument, you will see that in DSC, a secondary power source is connected with the reference and the sample pen. And the role of the secondary power source is to maintain delta T is equal to 0. That is the difference of the reference time, that is the difference in the reference and the sample temperature, right? For example, if you are taking here a polymeric sample, right, and if you are heating it, so there may be some endothermic or exothermic reactions will take place. And suppose if I say that endothermic reaction is taking place, so due to this endothermic reaction, there will be a decrease in the temperature of this sample chamber. So now this secondary power source will provide some heat so that the temperature will be equal to that of the reference, and the power that is provided by the secondary power source is measured in DSC. Now clear? Yes?
Yes, sir.
Yeah, that was the basic difference between the apparatus of DTA and DSC. Now, when you are analyzing a DSC curve, right?
Excuse
You
me,
will
sir, I have one doubt.
Yes, yes.
So why don't we have secondary source in DTA?
Because there was no need for measuring the heat change. No, we are in DTA, we are just measuring the difference in the temperature. We were measuring the difference in the temperature. But in case here, you are measuring the change in the heat. What is the
Okay, sir.
required heat that is required? Yeah, for that we are using DSC. Now, after analyzing a sample, you will get a curve like this. You will obtain this is the DSC plot for a sample, right? You will see that that is 0, that is which process? That is the endothermic process, then exothermic, and again an endothermic process, and that is straight line. So the curve above 0 is, the curve above 0 is
Exothermic.
It is
exothermic. Exo-
endothermic.
endothermic. Curve above 0 is, it means, what does
Endothermic
it mean?
reaction.
Yeah. So now you will see that if I am seeing a curve, you will see that for endothermic reaction, there is slight deviation in the curve, and for the exothermic, there is slight rise in the curve, right? Now, how to interpret this curve, right? So there are three values, that is the TG, TC, and TM. Now, one by one, we will discuss what is TG, TC, and TM here. Yes. So during the heating of a sample from room temperature to decomposition temperature, peaks with positive and negative delta H by delta T may be recorded. And each peak corresponds to a heat effect associated with a specific process such as crystallization, melting, or glass temperature. So first is the glass transition, right? So if you are saying this peak, this is TG peak. This is also known as the glass transition peak. Now, what is the glass transition? The glass transition in polymer is an important type of phase transition, and it is the temperature at which the amorphous non-crystalline polymer, that is the amorphous non-crystalline polymer, is converted from a brittle glass-like form to a rubbery flexible form. So if you are observing a peak like this, right, in a DSC curve, if you are seeing a peak like this, a slight slanting downward portion, a peak like that, that is a glass transition temperature. And this glass transition in polymer TG is the temperature at which the amorphous, that is the non-crystalline polymers, are converted from a brittle glass-like form to a rubbery flexible form. Vinayak. Yes. Now this glass transition involve a change in the local degree of freedom. Now what happened during the glass transition, right? During the glass transition, there is a change in the local degree of freedom, right? Above this glass transition temperature, there is segmental motions of the polymers are comparatively unhindered by the interaction with the neighboring chain. So if you are saying that at the start of the glass transition, above the glass transition at this point, what will happen? there is segmental motion of the polymers are unhindered by the interaction with the neighboring chain. And below the glass transition temperature, these motion are hindered greatly, and the relaxation time associated with such hindered motion are usually long compared to the duration of the experiment. And the motions are primarily torsional degree of freedom around freely rotating bonds in the long chain of the polymer. And the operative definition of glass temperature is that at this temperature or within a few degree, or at this temperature or within a few degree, the specific heat, that is the coefficient of thermal expansion, the free volume, and the dielectric constant all change rapidly. So during this period, a very short period, during this period, the specific heat, the coefficient of thermal expansion, and the free volume of the dielectric constant all changes very rapidly. So from TG, we can know about the mechanical behavior of a polymer, whether the polymer is amorphous or whether the polymer is crystalline. Suppose we are getting a straight line here. Suppose we are getting a straight line here. It means what we can say that? Yes, anyone? If you are getting a straight line here, it means the polymer is amorphous. It is not converting into crystalline or a flexible form. Yes? And if you are getting a slight deviation in the peak, then that is known as a glass transition temperature. And the glass transition temperature is a temperature at which the amorphous, that is the non-crystalline polymers, are converted from a brittle glass-like form to a rubbery flexible form. Now the second portion if you are saying the DSC curve, the second portion, that is the TC. This is known as the crystallization. If you are analyzing a polymer sample and if you are getting an exothermic peak, that is for the crystallization of the polymeric sample. And what is crystallization? After glass transition, the polymer has a lot of mobilities there, and they wiggle and squirm. It means there is a loss of mobility of the ions inside that polymers is taking place, and they are not in a single position, or they are randomly moving inside the polymers. And when they reach that right temperature, they will give off enough energy to move into valley ordered arrangement, and they which are called as crystals. So if you are providing a right temperature, these motion molecules in the polymers will rearrange among themselves to form the crystals. And when the polymers fall into this crystalline arrangement, that give off the heat. And when the heat is dumped off, a drop in the peak is observed, and you can see this drop in the heat flow as a big peak in the plot of heat flow versus temperature. So in the graph, you will see that there is a big drop in the peaks taking place when all the polymers have been arranged, or they are being arranged in a particular fashion, or they are being crystallized. The temperature at the highest point in the peak is usually considered to be the polymer's crystallization temperature. So the highest peak, that is at this point peak, is known as the polymer crystallization temperature. So from this you can know about the crystallization temperature of a particular polymer. So up to here we can know about the that is the glass transition temperature of the polymers, know about the amorphous or crystalline nature of the polymer. From this we can know about the crystallization process that is going on within the sample, that is the highest point where the crystallization taking place, right? And the third property that we are going to study using this TGA.
Excuse me, sir.
Yes.
Sir, is there any formation of mother liquor?
Yeah. Yes. Is there
Sir,
any?
Formation of is there any formation of mother liquor?
Mother liquor means?
Sir, the left out liquid after formation of crystals.
No, I am not saying about the liquid. I am saying about the crystallization of the polymeric material is taking place, right? Not the liquid, right? If you are taking a polymeric sample, it is converted.
So there are no byproducts.
There may be byproducts. There may be byproducts, right?
Okay.
For example, after crystallization, if you are stopping the process, the crystallization has been taken place, right? We know that the crystallization of the sample is taking place. Now, again, if you are more heating the sample, right? Again, if you are heating the sample, if you see the curve here, this one. If you are hitting the curve, then there is a endothermic peak is observed that tells us about the melting temperature. That is the melting temperature of the polymer is taking place. Now the polymer will start melting. Clear? Yes.
Yes, sir.
Yeah. So from the peak, from the crystallization peak, we can measure the area of the peak, and which tell us about the latent heat of crystallization of the polymer, right? And if you analyze 100% amorphous polymer like polystyrene, you will get this peak because such material don't crystallize. And because the polymer give off heat when it crystallizes, we call crystallization as an exothermic transition. Now, if we heat our polymer that is passed at point Tc, we will reach another thermal transition that is known as the melting. So the third peaks that you are observing in this TGA graph is that is the Tm, that is the melting point of that polymer. When we reach the polymer melting temperature, the polymer crystals begin to fall apart, that is they melt. And it comes out of their ordered arrangement and begin to move around freely. That can be spotted on a DSC plot. The heat which polymer give off when crystallized is absorbed when reached at Tm. That is the latent heat of melting, like latent heat of crystallization. So during the melting of a polymer crystal, they absorb heat in order to do so. So melting is a first order transition. This means that the melting temperature, the polymer temperature won't rise until all the crystals have been melted. So in the curve, you will see that endothermic reaction has been taking place when there is melting of the polymer, is when the melting of the polymers has been started. So from the DSC, you can tell us about the glass transition temperature, the crystallinity of a polymer, and the melting temperature of a polymer. You can easily discuss or usually tell about by seeing the graph. So DSC usually measures the glass transition, melting and boiling point, crystallization time and temperature, percentage crystallinity, heat of fusion and reaction, specific heat capacity, oxidative thermal stabilities, rate and degree of cure, reaction kinetics, and purity that can be measured using DSC. Now, the major applications of DSC is it can be used to measure the enthalpy of transition such as melting, crystallization, and fusion of polymeric materials. It can be used to calculate the percentage crystallinity of polymer. For example, is given a percentage crystallinity is calculated using percentage crystallinity is equal to delta HF of the sample divided by delta HF of 100% crystalline sample into 100. It can be used to check the purity of drug sample, which can be determined within 1% error. It can be used to determine the melting, boiling, and decomposition point of organic compounds and organic compounds. Now, what is the major difference between DTA and DSC? So when we are seeing, when we are using DTA and DSC, what is the major difference? In DTA, a graph is plotted between delta T and TR. Delta T is the temperature difference between the reference and the sample. So in DTA, a graph is plotted between delta T and TR, whereas in a DSC, the graph is plotted between the change in the heat versus the temperature. The size of the sample in DTA is 5 to 20 milligram, where the size of sample in DSC is 2 to 10 milligram. The specific heat measurements are not accurate in DTA, while in DSC you can easily measure the specific heat measurements. DTA second order phase transitions cannot be observed in DTA, but in DSC you can observe the second order phase transitions with a sample size of 200 milligram. In DTA provides calorimetric accuracy in the temperature range minus 190 degrees centigrade to 1000 degrees centigrade, whereas the accuracy in DSC is minus 170 degrees centigrade to 750 degrees centigrade. In DTA, the secondary power source is not required, whereas in DSC, a secondary power source is necessary for supplying heat either to the sample or reference so as to keep their temperature equal. Right, these are the main difference between DTA and DSC, and it has been asked many times in the exam, what is the major difference between DTA and DSC? So these are the 8 points That is the major difference. Now, when we are talking about the difference process that is going on DTA and DSC, that is causing the change in the heat temperature. So there are some endothermic processes and exothermic processes that are causing the changes in the heat and temperature. So what are these processes? If you are talking about the physical process, then physical process are adsorption, deabsorption, the change in the crystal structure, crystallization, melting, vaporization, and sublimation. And due to this, there may be some exothermic or endothermic reactions that is taking place within the sample. And the chemical process resulting in exothermic and endothermic reactions are oxidation, reduction, breakdown of the reaction, chemisorption of the sample is taking place, or a solid state reaction is taking place. So these are some of the physical and chemical processes that are taking place within a sample, resulting in change in the heat or temperature of the sample. Yes? Clear, all of you? Or you want to ask anything?
No, sir, clear.
क्लियर हो गया आप लोगों को क्या क्या प्रोसेस हो रहा है, क्या हो रहा है, कौन सा एक्सोथर्मिक और एंडोथर्मिक प्रोसेस की वजह से आपका हीट सॉरी चेंज इन टेम्परेचर होगा? यस?
Yes, sir.
Yes, sir.
And what is the major difference between DTA and DSC? So in exam, many times it has been asked to draw the instrumentation of DTA, TGA, and DSC. What is the difference between DTA and DSC, right? How DSC can be used to calculate percentage crystallinity in a given sample. So you can, so that the percentage crystallinity can be calculated using the given formula, right? What are the major application of DSC? How purity, write a question. Yes, everyone write a question. How, which method can be used to calculate or can be used to calculate the purity of a given compound? Yes, which method can be used to calculate the purity of a given compound, or how can we calculate the purity of a given compound? क्लियर? तो नेक्स्ट क्लास आप बताओगे कि अगर हमें प्योरिटी डिटरमाइन करना है तो कौन सा मेथड हम यूज करेंगे? यस एनीवन, व्हिच मेथड कैन बी यूज्ड फॉर द प्योरिटी डिटरमिनेशन ऑफ अ सैंपल?
DSC.
Why not DTA? DTA can also be used, but DSC you can measure accurately. Like how you can from using DSC, how you can know about the purity of the sample? Yes, anyone?
So with the help of delta H formation.
With the help of delta H formation. So first we will take a reading for the pure sample, right?
Yes.
Then we will analyze for the sample that you have been provided, and that the difference from that you can calculate what is the purity of the given sample.
Yes, sir.
Yes.
Yes, sir.
Yes, anyone? You anything or you want to add anything in this? कुछ ऐड करना चाहते हो आप? How to determine the purity of a given sample? फिर आपसे जब प्योरिटी की बात हो तो उसमें आप ये मत लिख देना कि इट कैन बी एनालाइज यूजिंग वॉल्यूमेट्रिक एनालिसिस. बहुत लोग ये लिख लेते हैं, वॉल्यूमेट्रिक एनालिसिस से भी हम प्योरिटी पता कर लेते हैं. डोंट नो हाउ. Yes, anything you want to ask? Now, if you are saying a TGA curve, yes, the last class some of you are asking example of a compound, an example of a samples TGA curve, example of TGA curve. So this is a curve showing the decomposition of calcium oxalate. So this is the TGA curve. You will see that this is a TGA curve showing the decomposition of calcium oxalate, that is CaC2O4 H2O, right? So this is what type of curve? TGA curve. Actually this green curve, what type of curve is this? Yes, this is multi-stage decomposition, because all the products you will see that you can easily differentiate the form byproduct. You will see that at nearly 150 degrees centigrade there is liberation of water molecules taking place. So if you are taking 0.8753 milligram of the sample, there is 12.57 reduction in the weight of the sample, right? From the TJ curve you will estimate how much of the weight loss is taking place in the first step. In the second step you will see that at 420 degrees centigrade to 460 degrees centigrade or up to 500 degrees centigrade, there is loss of carbon monoxide. And when you are increase the temperature to 600 degrees centigrade, there is liberation of carbon dioxide from the sample, resulting in the formation of calcium oxide. So you can see that there is, this is the TGA curve for the decomposition of calcium oxalate. So first step, the calcium oxalate monohydrate is converted to calcium oxalate. The second step, the calcium oxalate is converted to calcium carbonate, while in the third stage, the calcium carbonate is converted into the calcium oxide. And similarly, you will see this curve. And what this curve represents? Yes, you will see a three curves here. Yes, blue curves. What this blue curve represents?
So the peaks are representing endothermic or exothermic reaction.
But what is this? This is endothermic or exothermic?
So this is exothermic.
Exothermic. Why it is exothermic? We are saying that water is been released from the system, right? Water
Yes,
is
sir.
released from the system. So if water is released from the system, then it is
Uh,
exothermic process or endothermic process.
Sir, it is sort of dehydration, so I think it is endothermic.
That is endothermic. That is vaporization is taking place. Now,
Yes, sir,
vaporization is
endothermic.
taking. So that is a endothermic process, right?
Yes, sir.
So if you are analyzing a sample, we are going for the DTA and DSC analysis. For a sample, for example, I am saying that for calcium oxalate, you will obtain a TJ curve like this, right? Clear? Clear to all of you?
Yes, sir.
Yes, sir.
Yes. Any question you want to ask? In this unit, that is TJ and DSC. So just to summarize this, I will stop this presentation and we will go to another presentation that was on TGA. So the screen is visible to you, thermal analysis. So in thermal analysis, yes, screen is visible to you.
Yes, sir.
Yes, sir.
Yeah, in thermal analysis,
Yes,
we
sir.
have discussed about what is thermal analysis, right? Different method that we have to study, that is differential thermal analysis, differential scanning calorimetry, and thermogravimetric analysis, right? First, we have discussed about thermogravimetric analysis. What is TGA? What is the basic principle in TGA? Instrumentation of TGA. What is the basic instrumentation that is being used in TGA? And what is the graph that is obtained in TGA? Then we have interpreted a different type of graph, right? What is the horizontal portion? What is the horizontal portion? What is the slanting downward portion? Different graph that is obtained in TGA. How you will interpret the graphs? What are the factors that affect the TG curves? Affect the TG curve. That was the that was the instrumental factor and the sample characterization. Then we have discussed about the application of TGA. That was in qualitative analysis and quantitative analysis. And we have discussed about DTA, that is differential thermal analysis. We have discussed the principle. Then we have discussed the instrumentation. You will see that the instrumentation is similar to that of DSC. Only here a secondary power source was used. Here only the secondary power source was used in DCS. Suppose I put the both instrumentation here, right? This is for DTA. Let me copy the instrument for DSC. So this is the instrumentation for DSC. On your right side, it is DSC. On your left side, it is DTA. So you will see that there is not a major difference between the two apparatus. Only in case of DSC, there is a secondary power source that is being used. दिख रहा है सबको? Yes.
Sir.
Yes, sir.
Yes, sir.
दोनों इंस्ट्रूमेंट दिख रहा है ना, क्लियर, आपको क्लियर हो रहा है ना दोनों के बीच में डिफरेंस क्या है, राइट? अगर मैं हम टीजीए को भी लेके आते हैं, लेट्स पुट टीजीए आल्सो हियर, राइट? So these are block diagram representation for all the instrumentation. So this is for TGA, right? Yes, clear now, clear to all of you?
Yes, sir.
When you are seeing the instrumentation of all these, right? Now what you have to do, आप घर पे क्या करोगे? हमने तो इंस्ट्रूमेंटेशन डिस्कस कर लिया, ठीक है? आप एक बार जाओगे, नोट्स किस पे बनाओगे? The instrumentation I have given the block diagram, right? In case of TGA, I have discussed what is the furnace, how it is controlled by sample holder with microprocessor control unit. For DTA and DSC, you have to write about the instrumentation, right? This is the pictorial represented, but you have to write something about the instrument, right? What is the microprocessor control source here? What is the reference here? What is the sample pen? What is the reference in DSC? What is the sample pen? It consists of what? Platinum, aluminum rod. You have to make a note, or you have to make a short note on the instrumentation of DSC, DTA, and TGA, right? Clear, everyone?
Yes, sir.
So that is your home assignment, right? In the next class, be ready with that. I will ask you to upload that, right? Or I will see you directly. You will upload it as a presentation. You will take a snapshot of that and you will upload it. I will see that. Clear?
Yes, sir.
What you have written? Yes. Any more thing you want to ask? Any questions?
सर एग्जाम्स 4 जैन से ही शुरू हैं क्या, बाद में है?
4 जनवरी से एग्जाम है, डेट शीट आ गई है क्या आप लोगों की?
नहीं नहीं सर, एक पीडीएफ थी मेरे पास, शायद वो पुरानी है, पता नहीं, 4 जैन लिखा हुआ था उसमें।
अब शेयर करो जरा, मैं भी देखो कौन सी पीडीएफ है। शेयर कर सकते हो आप? मैं इसको अपनी स्टॉप करता हूँ, शेयर करो जरा। लेट्स शेयर विद द क्लास। आई थिंक आप लोग में एग्जाम,
एक
लेट मी
मिनट
सी,
सर।
या नो प्रॉब्लम, लेट मी सी। फोर्थ ऐसा कोई तो एग्जाम है नहीं।
सर विजिबल है मेरी स्क्रीन?
अभी आ रही है, देखते हैं। नहीं, आपके स्क्रीन में वो चीज नहीं है जो आप दिखाना चाह रहे हो, वो नहीं दिख रहा है, बाकी सब दिख रहा है। That is a class test. That is a class test, right? It is between 4 to 15. That is class test, right? That
हाँ
is a
ये
class
सर।
test between 4 to 15. That I will announce, right? कि अगर next week जब भी होगा, मैं एक वीक पहले बता दूंगा। इस वीक में कभी भी आपकी क्लास टेस्ट हो सकती है, और वो सरप्राइज टेस्ट है बेसिकली, है ना?
अच्छा अच्छा।
तो जो क्लास
ठीक
टेस्ट होगी आपको बता दिया जाएगा कि कहाँ से कहाँ तक होगा, टॉपिक क्या क्या इंक्लूड होंगे इसमें, है ना?
है, यस सर, ठीक है, थैंक यू
I
सर।
think 2 weeks are there, 4 to 15 ना, 2 weeks are there, and we will inform that which week आपके किस वीक में क्लास वो टेस्ट हो सकते हैं। So clear? Anything more you want to ask regarding the notes or yeah, yeah?
The notes you shared on the classroom for DSC are different.
नहीं, same है, almost same है।
No, sir, they contain less number of pages when you are presenting.
Okay, आज हमने कुछ और स्लाइड्स ऐड किए ना, that I will add, right? I will replace that slide and I will add this slide, right? मैं ये स्लाइड ऐड कर दूंगा उसमें, है ना? आप प्लीज कंपेयर करते रहना, अगर ऐसा दिक्कत हो आप बताना मुझे, मैं आई विल ऐड दैट स्लाइड, बिकॉज़
So I was
समटाइम मैं ना, हाँ
comparing,
मैं,
that's why I came to know about this.
क्या 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 हुआ?
Sir, sir, I
अच्छा,
was
कंपेयर, ओके दैट्स नॉट अ प्रॉब्लम। वो आई विल ऐड दैट। इन्वॉल्यूमेट्रिक एनालिसिस भी 2 पार्ट में था, तो मैंने एक कॉमन स्लाइड्स जो थी उसकी वो ऐड कर दिया। इवन आई विल आल्सो ऐड सम लेक्चर नोट्स आल्सो, पीडीएफ of book also in that, so that you can just go through that, okay? The theoretical portion you can go through that, right? कि आपको ढूंढना ना पड़े ज्यादा आपको मटेरियल। Yes, anything more
Thank you, sir.
regarding the online class? कोई problems है आपको? और apart from the technical issues,
सर आज एक दो बच्चे से ज्वाइन नहीं कर, लेट हो गए सर,
नहीं
टाइम वाला
लेट,
थोड़ा वो हो गया था
नहीं
सर,
लेट, देखो
मिसअंडरस्टैंडिंग।
अगर टाइम टेबल चेंज होगा दैट आई विल इन्फॉर्म, राइट? वो तो टाइपोग्राफिकल एरर्स थी, अकॉर्डिंग टू द टाइम टेबल ही चलेगा आपका। इफ देयर इज अ चेंज इन अ टाइम टेबल देन
नो
आई विल इन्फॉर्म द
प्रॉब्लम
क्लास।
सर।
हाँ वो हम पहले ही इन्फॉर्म कर देंगे आपको, है ना? एट द टाइम ऑफ द क्लास नहीं इन्फॉर्म होगा तो वो टाइपोग्राफिकल एरर्स था, है ना? आप वो शेयरिंग बंद कर लो, अंश शेयरिंग अपनी क्लोज करो। यस, यस, एनीथिंग मोर रिगार्डिंग द क्लास? और कुछ आप मतलब क्लास में और कोई प्रॉब्लम्स आ रही हैं?
सर एक बार आपने जो होमवर्क बताया उसके बारे में दोबारा बता देंगे हमारा?
क्या होमवर्क बताया मैंने?
सर ये जो आपने ग्राफ वो मतलब टेबल बताई आपने टीजीए टीएससी।
ये टेबल नहीं है बच्चे, इंस्ट्रूमेंटेशन है उनका, ब्लॉक डायग्राम है, राइट? इसकी डिस्क्रिप्शन आप लोगों को लिखनी है, इसकी डिस्क्रिप्शन लिखनी है। What is balance? What is furnace? What are the furnace used? What is the temperature range? Why microprocessor control power source used? ये सब आपको लिखना है, नोट्स बनाना है, एक पेज शॉर्ट नोट्स बनाना है ना? Now clear?
यस सर।
So let's end for the today's class. Next class we will discuss third unit, that is spectral method of analysis, right? That is spectroscopy. Saurabh is there?
ओके
Saurabh
सर,
is
यस
there?
सर।
So आप अटेंडेंस
यस
मुझे
सर।
भेज दोगे? अटेंडेंस भेज दोगे? 50 स्टूडेंट्स आर
जी
देयर।
सर। जी सर।
ठीक है,
जी
आप
सर, मैं
मुझे
आपको
मेल कर
एब्सेंटीज
दो।
का रोल नंबर।
Exactly,
ओके
exactly.
सर।
Thank you so much all of you and good day.
बाय।
बाय सर।
थैंक यू सर।